Hi everyone, I'm really excited to interview Theodore Galanos, who is currently senior researcher and project leader at City Intelligence Lab at AIT. He works at the intersection of design, data, and intelligence and specializes in the development of advanced computational design tools for AEC industry. His current work focuses on bespoke machine learning workflows which produce meaningful and measurable outcomes across vast design spaces. So without much ado, we'll jump into the interview. Mr. Theodore, can you share your journey of becoming a design technologist? Yeah, from college to what you are today.
Sure. First of all, thank you for inviting me. It's a great pleasure. And please, no, Mister, is okay. It makes me feel old. But my journey is, I guess it's a pretty mundane one, even though I didn't really start with the ambition to be in the AC industry. So I trained as my bachelor and my master's was in mechanical engineering, which I almost never practiced in its full term. Like, so I was never doing like, mechanical engineering drawings or like, fire protection, this kind of stuff. And after that, I went through a couple of jobs that I was looking into what to do. And then I decided to do a master's in industrial ecology in TU Delft. And industrial ecology is what today, this was maybe like 10 years ago. I think today the name for industrial ecology is circular ecology, right? Circular economy. So that's what it was, pretty much a sort of a view on how you can do sustainable development and consumption and production systems. And while I was there, I got a pretty broad understanding of sustainability, but I still didn't find how to apply myself. I'm still there. And I started working as a quality engineer. Again, a job that had almost nothing to do with what I had done. And after a while, I realized that I didn't really like what I was doing, and I left for Malaysia, where I am now. So I really came here with not really much to go on, just an internship and a very exciting, prospect, which very promptly actually changed. So like my internship kind of like stopped everything. I had an accident, I remember. So out of a situation where I didn't know where to go, I found my opportunity in the AC, and this was my first kind of job in the field around 7 years ago, I think, as an environmental designer. And what we were doing was environmental design engineering and a lot of like certification, compliance, and practical implementation stuff, project-based stuff. And I was very, very lucky back then to have a director who saw my passion and kind of like how I have this thing where when I see a strand, I want to pull it and see what is behind there. So I started reading and testing new things. I quickly went to Rhino and Grasshopper. Then I quickly found Ladybug tools because it was very fitting to what I was doing. And I kept researching in a way. And through the years there, I had the space and opportunity to research and develop myself. And this is how I became a computational designer in a way in the first few years of my job. And towards the end of that, I realized that most of the things that I wanted to do and the industry wanted to do, so like how do we do computational design at large scales, complex studies, how do we understand, like extract design intelligence was impossible. Like most of us, even the biggest companies, right? They say, oh, this is a parametric optimization, but I would check their blogs and it was like 10 alternatives. And even my projects, I had to do like one study because it took 3 weeks to run. And all these issues, like, they had me a bit distressed, and I decided to quit. So at that point, I quit, and I focused full time on machine learning and developing these tools that we're developing right now with CIL, like infrared. And that was kind of like my whole journey through this. It was a bit serendipitous how I reached here, but it was led by, let's say, a lot of passion and the need to solve some problems, let's say, I faced on the way. I don't know if that makes sense.
Mhm. Yeah, I think that's quite interesting how your interest and you evolved in this whole journey. And can you share what's your definition of sustainable design?
That's interesting. So I guess like I guess the basic definition would be, like something that in terms of, let's say, not just environmental impacts, but how it treats the occupant, it offers something back. So like I think I'm more leaning into a sort of like positive design, like in the sense that it brings something back to not just the environment, but the built environment and society and occupants. So my definition would be that I'm not so much. I mean, I understand the need for sustainable design in terms of like net zero design, passive design, all these approaches. They are very important incremental innovations. But for me, true sustainable design is not simply, buying renewable energy from somewhere else. It's designing with your focus on the occupant and with an ability to bring something to your surroundings, to the built environment. So,
Can you recommend some tools or workflow which helps to achieve that?
okay, sure. I mean, I don't believe there is one set of tools or workflows that could do that right now. The second aspect, anyway, is the positive design because it requires many more disciplines than just an engineering or environmental design discipline. But I think the approach, and I'm very biased because I'm a member of the community. I think the approach of Ladybug Tools is correct. Not in terms of the specific tools we are using, even though they're very good in what they do, right? Environmental design, but in terms of the philosophy of a modular approach. So the idea of Ladybug Tools was a tool set, right? Where you can combine, reconfigure in different ways to solve different problems. And sometimes in new ways, you could generate new studies. Like for example, an outdoor thermal comfort method that we developed with Chris Mackey, who is one of the developers and of Ladybug Tools. It came about by combining a few tools that they had made, but not for this exact reason, even though it was something. So I think that would be the approach, a sort of modular design in a way, not design, modular computational design that partly would be tools like Ladybug Tools. Another part would be machine learning tools and machine learning models plugged in together. And another part eventually would be, I think, I call them like, let's say, uh, some sort of environments of experience, because a lot of the things that we lack in right now in architecture, engineering, design is kind of visualized to ourselves or these design spaces and this process. So Grasshopper right now is you prepare a parametric model, which has a lot of domain knowledge and some understanding, and then you run something, and then at the end you get a result. So this in between is lacking a lot. And I feel we are lacking this sort of design tools that would give a glimpse of that between. The closest I can think of right now is gaming. So games do that, and the gaming environments and developing environments like Unity and Unreal kind of provide that, but it's not there yet. So I would think like eventually they will become a part of the process, and that would be it for me. And VR and AR and all this stuff, it's helpful, but not crucial for these first steps, I think.
Mhm. And how does a typical day in your life look like?
A typical day in my life. Wow. Okay. So I'm working remotely, even before actually this pandemic. So my work life is a bit different than most people who work in the office. Let's say, right. The other major difference is that I work from Malaysia, where I am now, in Europe, where the Cities Intelligence Lab is headed. So my colleagues, I work in a way in European time, right? So my morning is a sort of always wake up when they're sleeping in a way. So I have to do I in the morning I do tasks that are related to the work, and I also every day at least 1 to 2 hours a day I will devote into reading something new. So sometimes this is guided in the sense like I have a very big list of like papers that I want to go through and books, and but sometimes this is random. So for example, a good thing to do that is a sort of like stream of consciousness things. Like you go on YouTube or somewhere that is not very distracting, and you start from a subject and you follow the thread. So I do that sometimes. And most of the other hours is just like work related things. Like there is some meetings, you can't really avoid them even remotely, unfortunately. So there's like project meetings and collaborative meetings, and then a lot of work in the computer. And the rest of the time, because I work from home, I get to see my kids. quite a lot. So there is like this continuous kind of like interaction, which is nice. And yeah, lately with the pandemic, that's pretty much it. So there's not a lot of going out here. But yeah, I would say that there is a lot of like work related load and a lot of sprinkled in a lot of like exploration. I think it's very important to do this sort of exploration even without a goal, especially without a goal.
Mhm. If you can name one book that had the biggest impact in your life, what would that be and why?
So yeah, this is gonna be probably not what people expect. So the biggest impact in my life happened, I think, where really things clicked and I started thinking differently happened in my master's in the Netherlands. And what happened there is during my preparation for my thesis, I went into philosophy. Like seriously went into philosophy, not like I used to do it in high school where I just read a couple of pages. And I read my favorite philosopher even now, which is Alain Badiou, and I read his logic, like being an event and logic of words. So it's a very very difficult to traverse book, but it kind of opened my eyes in what I call dialectical thinking and what most people nowadays, because they're not so old school, they call complex thinking is the same thing. So what we call a complex thinking is what dialectics used to be a few thousand years ago. And it opened my eyes into this idea of not trying to think of things analytically, like what is a good and a bad, what is the the positive and the negative, what is the benefit and the disadvantage, but understanding that there are interrelations, understanding that both of these things exist in the world. So, and I think those books, especially by you, but a lot of other like string of philosophy books, that part of my life was the most important because this critical thinking and understanding how to see these relationships is really my biggest asset right now, like it will be for the rest of my life. Not my experience, not my degrees or my the tools I develop, but this ability of looking through these relationships.
Mhm.
So yeah, I highly recommend philosophy. And if people don't like continental philosophy, which by you is just any philosophy that critically analyzes something.
Yeah. What's the name of the book?
It's the Being an Event. It was the first book, and the other is Logic of Worlds. So yeah, they're not very light reading. Yeah, but in general, I recommend videos. So for example, you can find there is a very nice European graduate school channel on YouTube that has a lot of lectures by many philosophers, like philosophers, current philosophers, and Badiou has lectured there a lot, and he's a wonderful lecturer, and they're all up. So that's another way of approaching it. And what he helped me do, and especially this is very important in what I'm doing now, is he helped me frame how to frame. He helped me in how to frame novelty, what is new. Because a lot of the times people talk about innovation and this is amazing and a new thing, that everyone is talking now about the new modern, the new normal. But I think this is what philosophy and critical thinking allows you to think, ask the question: Is this really new and is it really normal? So he helped me do that a lot.
Mhm. Who is one mentor or role model who made a significant contribution in your life?
So mentor and role model. I think in respect to like the industry itself. So like my work in the industry, my director in my first job, I think was the biggest mentor, and he did it in a very nice way, not by guiding in a way on the time and stuff, but by just giving me the space to explore. So that was probably the best thing that anyone could have done for me back then, and it really gave me the ability to be where I am now. So I think that was like the real life matter. And then of course like my parents, because it's hard to explain, but I was raised to be like inquisitive, very critical, and sometimes very annoying in a way in this sense, because my parents were like that. They always they never told me, believe in this, it's okay. They always kind of taught me to look things through, and understand why. So I think, yeah, those are good, good role models to have.
Mhm. Can you share challenges faced in your career and how did you resolve those?
Yeah, I think like okay, the biggest challenges are I think there are very challenges that everyone faces. So the first challenge is how to begin, right? When you start, and especially now you can see like let's not discuss about the recruiting and how these job postings look like. Like you need to have like 150,000, years of experience. So the very difficult thing for young professionals is how to start, right? What should I do? And so that was my biggest challenge. And again, my first opportunity was also an opportunity that, someone saw in me something like a potential, right? And and so that was the biggest challenge at first because I didn't know how to apply myself. Like how would I? And even the challenge before that actually was where do you apply yourself? Because a lot of people, like especially growing up in Greece, a lot of people, even from early high school, they were like, "I'm gonna be a doctor." Like why? Because their parents told them, society told them, it's a good profession, you make money, it's a nice. So a lot of they had this future like set out. I didn't really have that. I always wanted to spread around, and I realize now, and especially reading some nice stuff right now, like theory of this, that it really helped me being a generalist. So it helped me by learning deeply, but not too deeply. It helped me to understand. Anyways, I'm diverging. So my first thing was like where to apply myself. It took me a lot, right? I started in the industry late, so I see young professionals that are brilliant, and they're like 24, 25 years old. They've done like so many things, and I started later than that in the industry. So that was the first. The second is when you start, and especially when you're late, there is a sort of stress. Am I going to find the experience? The opportunity. The only thing I can advise there is that when you find it, and you will find it, I mean, if you look for it, you will find it, is to not be complacent, to really, if you really love this job, like just do it, like full on. And by that I don't mean like stay in the office up to 10 o'clock to show that you're working, but like dive into something. Like when you're doing a project, and this is why my first experience when I had projects, I was given tasks. Okay, why don't you do this? And the first task was very simple, like maybe an Excel sheet and calculations. And I remember the first thing I was doing is like, okay, what is this task? Why am I doing it? So I started Googling, and I really recommend Googling to everyone. Like I don't want to promote Google, but searching, right? And so I started searching. Why do we do this? Okay, why is this? Oh, thermal comfort or thermal performance. What is the? So I follow these strands, right? And this is my biggest recommendation to once you get the chance, really dive into what of that thing is passionate. If you find yourself, and I found myself before this industry, that in the positions where there is no strand to pull, and most of your time is looking at Facebook and Twitter, then quit. That's the other advice I can give. Like really quit is not worth it. That's the reason I quit, and I found myself where I am today, right? And so that's the other. The next challenge is where you start to pull and dive into, and when you get more experience and more responsibility, the next challenge would be not to get burned out. So this is actually a very big concern because on the one side, obviously where you're working, they want you to work and do more things and do the things that you need to do, but you want to develop yourself. And it's very easy to get down in the rabbit hole of this kind of like research and okay, new tools, new ideas. So it's very important not to get burned out. The minute you realize it, it's worth to sacrifice even like months or out of it to escape. So that's the other big thing because if it does happen, it's very difficult to recover. So that's my other thing. And then the last one, once you have this figured out, then maybe you're lucky like me to be in a position where you can research and find new ideas. Is not to get stuck. Not to stop asking things. And how I do that is not the big mystery or like something very new. I just keep finding interesting things and looking into them. That's it. So and always thinking like I don't think of myself as a researcher, for example. So always thinking like again we go back to dialectics and complex thinking. There is no research and practice. This split of research and practice is fake. It's an analytical thinking split that doesn't exist. So keep in mind that how you can research into ways to improve your practice, right? And if you do that, you will never get stuck into the same. So this is kind of like my biggest issues that I faced so far. They will be further down the road. I don't know about them yet.
I see. I think there were many key takeaways. So like it's never too late to start, and always be curious, asking why and going to the basics, and take some regular breaks, and also gathering constant source of knowledge to make you curious about some stuff. All
Yeah,
right.
exactly.
And now we'll move to our next section, which is about your professional work. So can you give us an overview about the projects you did till date?
So until today, or I'm doing today?
Like,
So we start earlier, right? Okay. So initially, the projects I was involved as a consultant were, real life, let's say, projects in Southeast Asia. So these you can imagine quite different projects that you get in Europe and maybe closer to the ones in the US. So big developments, mixed developments, high rise, everything is high rise here, and like master plans the size of a city and these kind of things. So that was my first kind of interaction with projects was immediately at that scale. So I was lucky in that sense because they were quite complex. And I won't mention everything that I've done, so just the highlights. So the next thing that I got involved with was environmental design and especially complex aspects of that. So, for example, thermal comfort, wind comfort, a lot of computational fluid dynamics, either indoors and outdoors. So I did a lot of that during my work as an environmental consultant. And after that, also my involvement at that time with the Ladybug tools in Butterfly. So I helped develop it. I'm not the developer of Butterfly. Mustafa did almost everything. I gave kind of my domain knowledge to it, right? And so that was a very, very, very nice thing also for me because the whole thing was that the community had given me so much that I remember this post. I asked like, what can I do back? I Mustafa, I put like two, three things that I kind of know back then, and Mustafa was like, hey, what about this? So out of that, Butterfly came out. So that was another thing that was involved. And after that, the things that I'm really kind of proud of and interested still today is on the machine learning workflow. So I started very simple. So like, the typical parametric optimization that we do, can I do it with machine learning? So this is very tabular data, vanilla machine learning, scikit-learn, like very, very simple stuff. And then I went to like sort of deep learning, computer vision, and things that we do today. So infrared is probably the culmination of all these things. And infrared is a is a product. Is going to be a product. Is in heavy development right now that allows for real-time urban performance and urban design, urban performance assessment and design. And this is something that directly relates to the problem I mentioned in the beginning, where I couldn't really do what I said I wanted to do because all these studies or simulations would take like weeks to conduct. So when I started the machine learning journey, the first goal was that, okay, can I do it in a second instead of a week? Can I do it fast enough so I can do it in a generative way, right? And I believe in the Cities Intelligence Lab, we have proven it to ourselves mostly because we know we've seen it work, and to some people outside, and we plan to do like more validation that this works. At a certain level of accuracy, that is enough, I think, for conceptual design. And so that was kind of the culmination of it in the sense of like the first step, prediction, right? And this first step is the most crucial step because if you can't do that, then nothing changes. You just go back to maybe a cloud-based approach that does it in a few hours instead of a few days. And then maybe 5 companies in the world can afford this, and maybe like 10 projects every year can do that, right? But the whole point of ideas like infrared is okay, how can a small house project in any country in the world, how can it afford to do this study without the expertise and maybe without the money and the time for it, right? So I think that this machine learning workflows, they will enable this kind of thing, so give democratized access. And with that said, that's my next step. And right now, what we are working now, the next step of like, okay, now we can predict in real time. Now what? So that's the big question, right? How do you use this? And how do you actually make design better? How do you make the design process better? And how do you make designers better? So this is our current kind of like questions that we're asking. So that's kind of like very, very rough outline.
And it sounds quite amazing, like the the diversity of the projects you worked on. And according to you, what are some roadblocks faced by AEC industry to adopt this kind of solutions?
Looks, I mean, this discussion, there's been a lot of ink like spilled in this discussion about AI and automation, right? I'm not probably the best one to speak about the business side of things. Why? I will attend, but there are other people that are much more aware about these things, right? I think that on the one side, there is not a lot of incentives to do a lot of the potential automation that you could do in the industry because a lot of the industry is built on top of the processes that are already existing. So this is very, very normal, right? In any kind of innovation, there's a sort of incumbent process that just wants to remain there, right? And the other is that we actually lack the knowledge and expertise, even though this is getting much, much better, because the AI industry, thankfully for us, is very open. So everything is open source. Like the latest model by the biggest companies in the world, you can find it right now on GitHub. So the industry slowly, at least since I started 4 to 5 years ago, right now, like there's many more people working on it, but still I think it's too little, too few. Like because you can imagine like this computational design industry, that section of the industry that we think is so big. I think it's so big because this is my environment is really not. Even in the biggest, more advanced companies in the world, it's like a small niche in there, right? Maybe 15 people or 20. So if like a few of them start to apply this automation and AI and machine learning techniques, it's still not enough, right? So the problem is this kind of making the first step, and this is why I, the only advice I can give to people is like just do it. Find something that is like problematic and try to solve it. Thankfully, I see more and more people trying to do that. So the knowledge is the other part. And I would say that like a few of the other issues like misunderstanding of what these techniques and ideas can do, like a lot of people are fighting it in the sense of like automation will like not will take away our jobs because it's like very superficial I think argument, but there are much deeper arguments that say what about creativity and what happens with the actual act of design and engineering. Are we going to lose that? And I think that's a big roadblock, a mental roadblock, and I think is a total kind of like again like false roadblock because I think if anything right now today we are losing creativity because we are constrained by our workflows, right? If I have like 2 months of conceptual design process, why? Because our construction process is 6 years, right? And my design development is 1 year, and out of that 1 year, I have maybe 2 months to work on the project in conceptual design because the architect will call you if you are an environmental designer, as I used to be, the actual architect and client will call you at the end. So it's all made so that this doesn't work efficiently, right? So if you have that, it's when is the time for design? Where is the time for performance design? Where is the time for generative design and look into your design space and find some design intelligence and articulate to the client? There's no time for all this stuff. So if anything, this is gone right now. And where I am right now, around me, there's maybe 50 construction sites, right? The Southeast Asia is built as we speak. And if I take a picture, it's very difficult to separate them one from the other. They're all the same, right? Why are they all the same? Because a lot of this process is based on cost and based on time pressure and based on limitations of technology. People just copy paste what they do. This worked before, let's do it again. So I think this creativity in design is already kind of lost. And in fact, AI and machine learning can help us bring it back by taking this stuff away and letting us not just by letting us sketch, because I don't know if people will go back to sketching. Like if they don't never sketched in their lives, they won't do it probably. But by giving you a technological way, a technological means of exploring design. Like I'm not an architect, right? So I would. It doesn't mean that I have a machine learning model predicting, so I will start sketching, right? I don't have maybe the skills for that, but it does mean that I can go through thousands of designs and maybe extract some knowledge out of it and intelligence, so that will help other designers in the group. So that's, I think, the big roadblock there is this thing of like creativity and are we losing it, and all this debate. Of course, it could happen that AI and automation is used to enable these processes, and this is the big fear that I have, is that we have all these amazing tools and we use them to do what we used before faster. So that's why I said that infrared, in a sense, doesn't want to do that, even though we can right now do 10,000 times faster than an urban simulation, let's say urban performance assessment. We don't want to give that to the world because that's not our goal. We don't want to give access to people that can just do fast simulations and do the rest as they did. The point is to change what you were doing, right? So yeah, I think that's the biggest. And then some of the other roadblocks, I think, okay, obviously the software and hardware infrastructure is kind of like, we're not open source at all. Like the last biggest roadblock that I can think of is how closed and walled off the industry is, right? Like I had this post on LinkedIn a while back, like the typical AI community process is a new paper comes out of a brilliant new state-of-the-art technique, I don't know. Okay, some of them are not, but and then the code is there open source on GitHub, Someone other else from the community went through the paper and wrote a big blog describing how to use it, and 3, 4 other people made case studies and shared everything for free. And then you see on the AAC, there's maybe like a post on LinkedIn, some news article, and then some images kind of like blurred out so you don't even see the technology used. And then maybe you have some workshops that cost $1,000 for 2 days, this is not going to work. So if you want these things to disseminate, you really need to be open source. And I think the companies in our domain, they haven't realized yet the power and value of this, right? And related, and I will stop with this because I can go on forever for this stuff. A related problem that this creates is talent. So a lot of people that start in the AC, right, they do it because they have a sort of calling, right? Historically, they were architects, designers, engineers, right? That's what we say, right? And that's why the whole apprenticeship exists, because you have a master apprentice and you are the apprentice learning, right? But this has changed now because I can do as much design as an architect does, and arguably more as a data scientist, right? It's just a different type of design. It's maybe a software engineering design where I can stack different technologies and have a brilliant result at the end. It's maybe a UI and UX design or front end, right? Where I can show and visualize things. So why is a young kid, not me, someone young and brilliant and talented, why is he or she going to choose our industry where they have to work as apprentices for free, essentially, for a few years, and not the data science or machine learning where they actually get paid and they work, like in a better probably environment and do interesting projects. So this will be a big problem going forward if we don't realize this power of open source. And the reason AI companies are so open, they don't open everything, but the reason why they are so open is exactly this. They don't do it because they are the best people in the world. They do it because they fight for talent. So that to get the best people in the domain, they need to let their people share knowledge. So I see that a lot in our industry where people from, they work for like prestigious companies, they have many ideas, they can't share their work. They can never share, I can't do it. And I think this will be a big roadblock in the future. People stay.
I see. What are some ways like we can change that scenario?
I mean, the easiest way is imitation, right? You can just say, okay, what are the others doing? So like software companies, they understand the open source value, like the software, I don't know if it's an industry, but let's say the software community, right? Software engineering is a very good community to get inspired from. And actually you do see this, like a lot of the very new kind of like uh, very promising startups in the AC are software startups in a way. I am kind of like hesitant on that, not about their value is complete, but I don't necessarily mean by all of this that we all need to become developers and software engineers. I mean that, engineers and designers and people who sketch, they are still valuable. It's just that they need to find ways to kind of open source their knowledge, right? And create a community where we can draw from that. So one way is imitation, right? That's probably the easiest way, but it's extremely hard because a lot of the structure, again, I'm not the best one to speak about the business structure of large AC companies, but I can imagine, and I've talked with people, that a lot of this structure is based on this, control of information. You see, like, you can see almost every other month, I don't want to say every week, maybe a few months, these new tools getting developed by, big companies with money to invest in this, right? And then the line under this tool would say this is our proprietary toolset. And the minute I see that, I know that this is utterly useless for the world. Like, it will be very useful for them, and even for them, not so much. And I can explain why. But for the world of the AC and perhaps the world at large, it will be useless because there is only one company, even if it's very big, using it, right? And it will never be developed properly because you can't draw the expertise and the creativity of the crowd of the AC. Other people cannot build on top of that, right? They cannot fix what you didn't do. They cannot think, the room is always smarter than you, right? So the room of the AC community is always smarter than any company, even the biggest. And so it's very hard because that's how we are built to work. So I would start by imitating, and then the other thing that you can do is at some point, and a lot of very smart people and much smarter than me have realized this, I think, is that there's no reason to really change you know how companies are doing things. Like, there's no reason to go to the big companies and try to change what they're doing. You can make your own company and disrupt them, right? So this, I think, will happen, and it starts to happen. Obviously, that disruption, because of how imbalanced our industry has been, especially in money wise, it can be like stemmed a bit by big companies buying smaller companies, and that will happen. But eventually, and especially now that they're becoming software companies and their margin of profits are much higher, I think eventually a lot of these aspects that bigger companies are either resisting or withholding, some other more innovative smaller startups will disrupt this completely, right? They become bigger actors. So I think this is what I see happening. So one is imitation, so everyone can imitate, even larger companies can start kind of working like Google, or like um, Uber, or not engineering companies like OpenAI, or to even better, like Hugging Face, or like these open source companies that are built completely on open source. They have no proprietary thing, right? And they are $1 billion valuation companies, completely built on open source. So you can do that, or you can start disrupting by doing that, right? So I think this is kind of solution.
Yeah, I think those are quite interesting thoughts. And what are some emerging trends in the field of computational design?
So I think, like, obviously, like, okay, machine learning is one, right? People are trying to apply it, and as I said, most of the applications are either to predict, so to make things faster, right, or to optimize, which I find kind of curious. So, like, especially a lot of reinforcement learning applications I see, it's kind of like the agent is another black box optimizing, but it's a start. It's a start. So that's the probably the biggest trend right now. Interestingly enough, and probably this is it's quite expected, we are behind in this. I think the AI, as it is now, and this is also my own intuition of the AI domain, and because I try to follow it closely, it's shifting away from that. So it's shifting away. Deep learning is there, will be there forever, right? It has a lot of value for a lot of people, and what you can do with it, predict, and even generate in some way something useful. It will be useful for businesses, right? And a lot of products out there in the world. But when it comes to intelligence, and if you want to talk design intelligence, AI is moving away from that. So it's moving towards, it's kind of moving backwards towards evolutionary design, and how you can do, especially the focus on novelty and what is new and what is creativity, how you can have creativity and diversity. And and so I think in the AC, it would be very nice to look back a bit, because we used to do that a lot, right? Even from the 90s, like evolutionary computation and stuff. So it would be nice to revisit that. But currently, I think the biggest trend is machine learning and its applications. The other biggest trend that I see is a sort of platform approach. So people, again, the startups that I'm saying that might disrupt other companies, they are realizing that the people need spaces where they can experiment and generate designs easier, like more streamlined. So they are building this kind of technological platforms connecting. everything. So I think this is a big trend in computational design. And another thing might be how do you kind of like escape from BIM? Well, like I understand the value of BIM and it will be a big part of the industry, but there are a lot of people trying already to think not to escape, but is there something after, or maybe like a more complete, information platform around our design, and how can it be also more open source? So there are a lot of people I see a current wave for open source and a few other, Blender being, for example, and a few other like software tools coming out, that is hopefully a trend to stay here. And yeah, I think those might be the biggest trends. And then unfortunately, I think the trend that is missing, and this might be me not being very informed on it, is the sort of like basic science. And so like I can say an example of energy simulation, right? It was the first simulation I did, right? I haven't done an energy simulation in a couple of years. One reason is I'm not doing compliance certification projects anymore. The other reason is it's not really useful, right? If you find one building where your model is actually the same as reality, and then I give you some money, like something like that. And the problem is not like, oh, the designer wasn't aware of it, or he or she wasn't good enough, or we didn't have time or to be too detailed. The problem is the fundamental kind of like abstractions in a lot of our simulation tools, they are not very good, right? So I'm hoping that there will be research on that also. So like, for example, that's why I went and I stuck to more complex, let's say, quote unquote metrics and studies like fluid dynamics, because they are much more developed, right? They can come closer to reality. Of course, there is always a scene to reality gap, right? But you are much closer to something that is actionable in the world, right? So I would like to see a bit more improvement on that, and a few studies and simulations and computational design studies to become like more useful, let's say. Yeah.
Mhm.
So that's kind of
Yeah.
that makes sense.
And like building upon that question, according to you, what kind of design applications which uses data and intelligence would be common 5 years from now, but are not used widely today?
Okay. So there's a few like dimensions to look this from. Like the first dimension is the obvious, like what is the easiest to use them on, right? So everything that is amenable to data analysis and data analytics, I think from 5 years from now, the first thing you will do is a sort of like data analytical step. So that relates a lot to like building information modeling. Why? Because most of it is a collection of data in a way, right? The sort of like 3D geometry is just I mean, probably this is controversial, but it's a beautification on top of data. It's not the important part in a way. It's much better to see a model in Rhino, much nicer anyways. But the value of build information model is the information. So people already are kind of developing a lot of tools to extract knowledge out of this data, or not real knowledge, information. The first step is that, because that's interesting. Like, I don't think we have building information model. Anyways, this is another big discussion. Maybe we have like building data models. Maybe BDM is a better aspect for just a simple bin, a file that I used to do the same thing I used to do. So this is just data. Information is like actually extracting some information out of this data. So I think that would be, and it's already, kind of everywhere, this data analytics part. And it's not very machine learning in the sense running a model and optimizing and like predicting and stuff, but it's a very big part. And actually, even in the work that I do, 95% of the part is preparing your data and understanding it and all that stuff. Maybe 99.5%. So that's the first one. So the easiest you can start with, and then the other part, I think the other easiest part might be things that are closer to business intelligence. Like people are going to start to do data analytics on efficiency and productivity, and what things that worked in our projects, and a lot of knowledge retrieval. So a very big application that I haven't seen still in AC is like natural language processing. There are some startups that do it in compliance or regulation, but there are very few companies that do it internally. So I think that's a very easy application. So where you have like a whole dump of thousands of documents from your projects, and you try to extract knowledge from there. And this is a quite old domain, like 30, 40 years already this is happening. So that's another easy one, I think. And especially the closer you get to construction implementation, that gets very important and quite good to do because there's a lot of inefficiencies there. And the other thing I think that is the easiest, not easy to do, but easiest in terms of like people see the value is anything to do related to construction, right? So if we consider that computational design, I don't know, maybe we can. So there's already a lot of startups that do a lot of things about tasking and how I can do it faster. I think there's going to be a lot of machine learning and AI in terms of manufacturing and offsite construction, both in the design part, but also in the, again, how do you deal with the data? How do you efficiently manufacture something and represent it nicely so that all the downstream and upstream systems can do it? So that's a big, and the reason there is because construction just has a lot of value to extract, right? It's very inefficient. It's the most inefficient industry in the world. So, and then lastly, in computational design, I don't think that in 5 years' time, everyone will be doing conceptual design with something like infrared, but we hope they will. But I think it's very doable. Like, I think, you know, if I was working, I would do it right now because I know it's doable. So I'm hoping people will actually catch up on that and start trying it and see that it's doable. And I would hope that maybe, you know, in 5 years, maybe like the simple at least studies and simulations and parametric optimizations and stuff will be done like this in conceptual design. And maybe in 10 years time or maybe earlier if I can manage or we can manage is to have like, you know, a sort of like tools for design intelligence. That's the best way that I can explain them, you know? So like sort of maybe generative design tools, maybe not, but tools that allow you to extract design intelligence. Like, so instead of, again, I go back to this idea of changing what you do. Instead of having all this amazing tool set at your disposal to solve the problems you have, right? You use it to create a new way of working, right? So the new way of working you can think of is designed to an environment where, you know, you can combine a lot of different tools and ideas and, you know, ways to explore and generate data to extract intelligence. So I see that maybe 10 years down the line, a bit more mainstream, right? I think that's it. Like, computational design will be the hardest, which is weird because that's where I applied it the first, and it shouldn't. But it will be the hardest because it's also like it's also like how valuable it will be. You know, like it's not that valuable. Like let's not kid ourselves. Like even the most sustainable companies in the world, like it's kind of like okay, you know, we need to do also your compliance, you know, like, but always the most important is like, okay, how is this built up? What is the cost like? What is, you know, so, and maybe one suggestion for me to apply these things in computational design is to take advantage that you can scale up things and put the other parameters that you typically kind of like don't put as cost, buildability, complexity of construction implementation in your parametric optimization, and then people will get interested because just the shortening of time is not going to be that valuable. I think it's going to be there is value there, but not enough to get funding internally first instead of something that improves construction, for example, right? Which can get much more. Yeah. And this is actually I saw it recently. I think the biggest one of the biggest fintech startups I saw has more valuation or like actually funding than all the AC together, right? And the reason that I think is because we haven't found this way to extract value, right? So yeah, that's what in computational design, especially in environmental design, my kind of niche is very difficult to do, and we need to find ways to do
it. And the last question in this section is there anything you wish you had done differently?
Yeah. Okay. So going back, that's the thing. Like, this is interesting because I've been reading lately this nice book called Rains, right? That talks about how important again this idea of novelty and how important to be a generalist instead of a specialist, right? For many years, I was thinking that, oh man, you know, I spent a lot of my childhood, you know, like, you know, going out, playing, working, you know, gaming, all this stuff, right? I did a lot of different things, right? Maybe I paused my studies to work for a year, to go to the army. We have to go to the army in Greece. So like all these different things, and I was like, whoa, I played so much of this game when I was young. Maybe if I was studying, like these things, I would have been much better. And I think no, like it turns out, I think that the reason why I'm good at what I do is because I took time to lose myself, lose the way. So in that sense, I don't regret how everything. I regret some of it, some scale of it. Like maybe I should have been a bit more curious at my university days. I tend to like most people, I blame others, like, so I blame kind of like no one was there to tell me, to point me, but I think it's mostly me, it's not others. So one regret I have from my university years is I did a very peculiar mechanical engineering course, which had a lot of, actually, you can piece a lot of my courses back then, and this is really amazing. I don't think they've still realized it, which is a bit of a, it shows how far behind they are, I think. But if you could piece half of my curriculum and you could make a reinforcement learning major in my, at 2000, right, when I was doing that, because it had like linear, non-linear optimization, it had like dynamic optimization, everything, right? But no one was there to kind of tell us, hey, look, if you piece this and this and this together, you could teach robots how to play football. I don't know. Or maybe I wasn't. So I regret not seeing it back then. I think it would be very nice. That's my only regret from back then. And from professional, like the only regret I probably have is like, at some points in my life, not taking decisions, to change when you know that you've had enough, like, earlier. But this is a very difficult regret because you can't really escape that. It's always like you're gonna second guess, and especially it depends where you are in life and stuff like that. But still, in hindsight, I would have made some decisions like faster, right? And I think other than that, I try not to regret too much because again, I tend to believe that even these mistakes, yeah, they help me to reach where I am. Yeah, and yeah, I don't know, like maybe the last regret going forward, and we will see if I regret it, is maybe have a bit better understanding of the business side of things. And this is a bit difficult because not everyone thinks like that, and this is okay. That's why when you're doing something, you collaborate, right? You can be good with on everything. But I think I might have, regretted not being more, taking more initiative on that side of like trying out something like that, and eventually I will do it. But that's a very minor regret because my goal is not really to have a big company and make money, not in the slightest. But it's a minor regret in the sense that it's a nice adventure to have, and at some point, I think it will happen.
Mhm. Now we will move on to our last section, which is advice to students and young professionals. So, what is the best advice you have received till date?
The best advice. I think it wasn't really a live advice. It goes back to the stuff I read. So, and especially from philosophy, I think, and the advice of that circle of philosophers that I work, and it's always look sort of this very old school critique of, I don't want to say the word is too weighty, but let's say critical ideology, right? So that's the best advice I had of like look behind in a way the curtain, right? Not in a conspiracy theory way, right? But like try to understand what is behind things. That's the best advice I got and the best advice I can give. Like what people usually portray as something, is not the real thing. Either because they haven't really looked into it, and that's okay because we are just one person, or because there is an incentive to display it like that. So I think the best advice I got was to how to think like that, how to look behind this incentive. Yeah.
Mhm.
I don't know if that makes sense.
Yeah, it perfectly makes sense. And what will be your advice to students and professionals who are interested to do similar work?
Yeah. So the first advice is all these time things about generalists, right? Try to be open to things, right? Don't over specialize. I think it's very, and it's curious because we've known this for decades. Like it's sort of a one of the many things that we learn and forget and learn and forget, right? I think there was a study in the 80s where in the UK, I believe, they took away all the sociology courses from engineering classes because they were like, why do you need this? Like, you don't need like to learn about, you know, sociology and philosophy and things like that, right? And what they realized, I think a decade later, they had like really good professionals, really good in their field, right? They knew how to do engineering, right? But they couldn't really create new knowledge, right? Because all they knew how to do was that, right? So my first advice is be a generalist, right? Dive into the things you feel passionate, but you know your knowledge should be a sort of like, you know, sort of fitness landscape with a lot of local optima, you know, just a lot of like things where you dug a hole and look into it, you know, and maybe you will find something that you want to go really deep and you stay there forever. It happens, or for a few years. But yeah, always have this idea in your mind that it's good to jump up and look around. You know, this is, I think, very important. And the other thing is to really be like inquisitive in the sense in the other thing actually is to work hard. And I don't mean by that, you know, work your 8 hours and, you know, be like responsible and all this stuff. But I mean, in order to do things like that, you have to devote yourself, right? And a lot of people have problems with that because by devoting ourselves, we align this sometimes to like, why should I work 10 hours? They don't pay me for that. I don't mean work and payment and responsibilities. That's another thing. I mean, you need to devote your own time into this thing. It doesn't happen just through working into a field. Like all this idea of like, oh, I'm going to intern there and then I'm going to work there and I will learn. It won't happen. Most of the internships that I've seen, you know, you can finish them and not learn anything. You can be there, you know, even when you're working every day on something they give you. So you really need to devote. And I go back to where I was working, where, you know, every time I had a gap, I would look into something. Like, you know, maybe I had lunch in my desk. It's not the healthiest thing. Don't do it every day. But some days, you know, during lunch, I would watch a video, right, of something new and only of the things that I was passionate about. So I would sacrifice some. So you need to sacrifice something, right? And down the line, this helps you a lot because then you realize that, hey, I sacrificed a lot of time before, but now I can do these things in like a couple of minutes, you know, because I really know my way around them. So the other thing is that you need to devote. Like it is really, you know, plain hard work. It's nothing more to it, right? And the other advice would be, I think, you know, always like, of course, be respectful with others, and you know, like when you work with others, be respectful, and but never kind of like feel that you're not worthy in the sense that because a lot of the times when we go to a new place and then a new place and then a new place, and as your career maybe, you know, maybe you go higher and higher, and maybe I don't know, like maybe in environments, professional environments, we tend to think that, oh, now that I'm here, I'm so little and small, and I need to. I think I found out that, you know, like sometimes, you know, everyone brings something new, and you know, I try to never feel that I'm like, okay, I'm not, you know, everyone else is smarter than me or more experienced. So I think you need to keep that in mind that, you know, you can be valuable at every environment, right? That's my last. Never like underestimate yourself. Of course, be respectful. Don't go there and say, now that I'm here, you know, everything is solved. But also don't be someone who's like, okay, I won't talk back or I won't like disagree because they must know more than me or something like that. So that's my basic advice. I hope it makes sense. Yeah, that's all. And then, okay, the last one, if you really want to learn something, that's my personal experience. Not like, all of this is personal. It's not like universal laws. Find the problem. So just find the problem. Without the problem, I can never. I've done maybe 150 hello world experiments, right? I've started coding in my life maybe 150 times, and I stopped every time at hello world. Every time, every single time. And the one time I went further than that was with how can I use machine learning to change computational design. So like I found a problem that dragged me into this. So I think that's very important.
Mhm. And what are some basic tools or software or applications you would recommend to a beginner in this field?
Okay, so for computational design, obviously Ladybug tools. Again, I'm biased. I think the community is amazing, and what they've given to the community is already amazingly. So just by going, if you start now computational design, just by going through the posts in the forum of the last 5, 6 years, maybe 10 years, how many they are, it will be like it will bring you up to speed to be like an expert instantly. So just the forums are enough to be an expert in a way, you know. So that's one side for computational design. And then when it comes to machine learning, it's really difficult to say a few tools because the landscape is changing a lot. But there is some obvious things there, like like I really like what Fast AI has been doing. It's like perhaps the one of the best kind of educational content for deep learning and machine learning, and it's completely free, right? Their library is also quite amazing and kind of like makes things a bit more high level. PyTorch is amazing. TensorFlow, yeah, okay. So the PyTorch is already in TensorFlow, let's say now, but nowadays. So those are really good, and I recommend them. Also, Scikit-learn. If you're just entering machine learning, start with Scikit-learn. Again, a very nice community, a lot of knowledge there. A lot of open source stuff. I don't know. Like I would definitely recommend things that I'm also not an expert in. I wish I was. So like Unity and Unreal, I would definitely devote time into that. I'm trying to do it now, but it's not enough time. But if I was starting back then, I would have done it. So like again, broaden your things. So not just do Grasshopper or Dynamo, right? For example, very recently I took up Houdini, and I realized, what I've been missing all these years. So like look around these other technologies. The same goes with Unity, for example. Try Godot or Godot, it's called. So it's an open source again, like gaming engine that's very light. So I would definitely work a lot with the gaming engines. I think they represent the kind of the next step for AC in a lot of domains. And what else? Yeah, I think that's it. And another thing that I like, but this is very recent, so I've been doing the last few months, and it relates to knowledge management and how you learn, is this new kind of network thinking tools where I would recommend finding one. There's a few open source, there are a few paid ones, and these allow you to kind of like save your notes and all that stuff for your knowledge and connect them to each other. So I think that's very useful, especially with how fragmented we are today. So maybe that's a very minimal description of tools.
Yeah. And when you recommend Unreal or Unity, is it for the visualization part or it's for other
No,
purpose?
I would say visualization is the last. It's amazing. And of course, that for architectural visualization, a lot of people are working there. They already use it, right? But no, I mean it as, generate an environment where you can simulate experience, right? For example, let's say right now, right, even in practice, when you're designing a building, you are literally designing it by a static, even climate-based simulation, let's say daylighting, right? But it's static at the end. Even if it's climate based, it takes into account the local climate and how the sun angles and all this stuff, the weather file. It's still static because the occupant is missing from there, right? So what is the next step? Maybe you have a sort of agent moving through that landscape, and you can have the agent like giving back information, like this is the signal I get from the daylight landscape that your simulation gave me, right? At every moment of time. So I think this is the next step where we need to go. We need to put the occupant in the center and create these environments of experience, of generating experience in a visual way, because we can't really look at terminals running reinforcement learning or agent-based stuff because we're never going to learn. It's just a terminal. And I think Unity, Unreal, Godot, these gaming engines, they give access to this, right? You can deploy this kind of simulation environments or setups in Unity, in Unreal, in all this experience, and you can visualize, right? And when that happens, two things happens. One, you can learn, and two, most importantly, you can explain it to others. Because if you can't explain it to stakeholders that have no idea about what is daylight, what it's based, like they're not going to understand. They're not going to understand, right? So you need to explain to stakeholders that, and they are the important stakeholders, why is this valuable, right? So I think those environments, they make it easier to do that. So yeah, that would be why I would use them. And visualization is that last part for communication, but it really has nothing to do with like very photorealistic stuff. It's just like communication.
Got it. I recently attended Digital Futures workshop in which there was one in which they used style transfer and machine learning to understand buildings and environment better. And there was one workshop on using Unity to simulate behaviors. So
Yeah,
a lot
that's
of
very good.
famous colleges are moving, like adopting courses and studios towards that direction.
Yeah, and it's a good career way as well because those companies are investing a lot in the AC, right? Because they understand that the AC is a big market and about to be disrupted in some ways. So, there is a lot of incentives. For example, I know for a fact that most of the tutorials now and learning stuff are free, right? So right now, anyone can start and becoming an expert in these tools, and also the open source tools, of course, like Godot, for example, everything is free. So it's a good time to do it. Very good time. Yeah. About the style, I don't know, it's a big idea. Like we didn't discuss about this, like what types of models I find useful. I understand the fascination of. I really want to put this in because it's just a rant I do with everyone. So I understand the fascination of generative design, right? I mean, generative models in deep learning, in the deep learning field, and how that relates to artistic creating new like designs and sketches. But I don't know. I just don't see that will be the value of deep learning. It's quite easy and nice in the sense it's easy because like aesthetic and creating creativity and all this stuff is a very difficult subject to approach, but it's also easy in a sense because you don't need to prove anything to anyone. You can just say this is nice, no, this is creative, like, but it doesn't have this normative aspect that we need in the world, right? Does this work? Does it make life better? Does it make the environment better? Is the occupant happy in there? Can I work? Can I fit my can I build it? Can I, all these questions. And the generative models, they don't do that. They will never do that. So the current iteration of deep learning generative models, they will never answer these questions. They can create alternatives, which is good. And most of these alternatives will need a lot of post-processing to become like conceptual designs, but okay. But they can't really say by themselves, is this good or not, right? And I feel, and maybe this is a limited view I have due to my domain of performance-based design, right? I feel that's important, and yeah. So yeah, style transfer is nice, but I would use it in different ways, and I plan to use it in different ways, in closely to what the name implies. Can you learn an architectural style? Yeah. So,
Mhm.
so that was my rant on generative.
Yeah. And what is one question you never get asked but would like to answer?
The easy way out is this question. You just ask me, and then we get into a loop that never ends. But I don't know. Good question. I don't know. Maybe this kind of stuff that I just ranted about. That's one question, right? Like why why do you think this doesn't work? This is a good question that I always want to answer. I think most people like to do that. When we have a strong opinion, we want to be asked about it. So maybe one strong opinion I have is about this, like generative design and how we can see it differently, because I think it has a very loaded history that I'm going through right now, and a lot of people have given up on it because of that history. And most people that do try it, they try it in that old way of like generating an artistic and new theories, which is very important. But yeah, I think we we can use like machine learning to view generative design in a new light. So that's a question people don't talk about, but mostly because it's not very interesting in a way for right now. For in terms of what we were discussing earlier, value and applications and all this stuff, right? So yeah, I mean, I don't know. I can't think of other runs, but but usually it's these things, right? My strong opinions that nobody cares about and no one asks, I guess. So that was one. It's a good example, the one we discussed before. Like, are generative models good for architecture, for design, let's say, and how they can be.
Mhm. And any conference you would recommend to students or professionals?
Yeah, like all the machine learning conferences I would recommend. They are quite expensive usually, but right now because of the pandemic, like I believe you could go to the ICML with $100, which is like 4 times less than the. This is like the second, maybe second biggest conference in the world. For like it has like I think they have like 10,000 or so papers submitted. It has workshops, everything. Which you can see for free anyways, without registering, right? So this is kind of like, compared to conferences, you need to pay like $400 for a VAC, and you get like 20 pay, like it's not. So I would recommend the conference for machine learning, and they're not everything about like, you know, new rips, and they're not just machine learning. You can check like, robotics conferences. Those are very interesting, especially for design, both for construction side, which is a very nice application of robotics, but also because in robotics they are obsessed with this idea of like how can I have novelty and diversity, because robots are not going to work well if you have the optimal design, because if you ask them to do something else, then they just get stuck, like, so they're not buildings that are static in a way, and even buildings are not static, but anyways, so they have an almost obsession of looking for novelty and diversity. So it's a very good places to look into. I like CMOUT from our industry because it's, of course I'm biased again because, like I'm doing like mostly like simulation and performance based work, but I feel it's very grounded, which is important. For the most part, it's grounded in the sense, okay, because I have this thing like a lot of the times that I talk to people, right? I seem like I'm up in the clouds talking about theory, but my obsession is practice. So if you're showing something, you need to be talking about, okay, how does this work in practice, right? Not because that's the only value you get. There is theoretical value and there is value in new theories, right? But at the end, you need to sort of try and make this up connected, right? And CMOUT is, by definition, is connected to practice in a way because you need to kind of run something and see if it works. And so I'm kind of like biased there from our industry, right? I don't think our industry has a lot of good content, unfortunately, in that sense of conferences, especially open source and stuff. Yeah. So I would start with, machine learning and robotics conferences, and then and even like 2 3 years old, I'm still watching them. So on YouTube you can find everything open. So I would check new rips for sure. ICML, ACL, I believe it's called, which is the natural language processing one. So all just look into machine learning. Yeah, there is a lot of like parallels there.
Mhm. How can our listeners follow you and your work?
Okay. So I'm almost like never ending, content on LinkedIn. So that's where I am. So they can follow me on LinkedIn, and I would be great. And I tend to connect to people, and I use LinkedIn. I feel I use LinkedIn for what LinkedIn is meant to be. So I've met and I've connected with a lot of people, like maybe hundreds, and I've literally connected, like spoken, like we speak now. So just shoot me a message immediately, and have a chat. That's the best way, I think. And I'm exactly the opposite on Twitter for some reason. Like I nobody knows me there, and like I post sometimes and no one sees it. I don't know why. I've never like took active time. Probably because as people seeing this video realize I talk too much, and Twitter is like all about talking a little. So it wasn't very, yeah. But I'm trying there. But I think LinkedIn is the best place. Yeah, and then in the Ladybug Tools forums, I try to be a bit, as much as I can in the things that I can help with, active. So if you're doing something there, I will be around. And I think that's the best place.
All right, that's it. Thanks a lot for your time. It was a great interview.
Yeah, thank you, Mary. Thank you. It was great having you. It was great being here.